Welcome. In this video I'm going to show you how you can perform a one sample z-test using Microsoft Excel. I have a separate video where I explain how you can do this with my add-in, which actually simply has a function that can do this. But in this video I'll show you how it can be done without. I have some example data stored in column A, and the first thing I set is my hypothesized mean. I then need a sample size, so for that I can simply use a count function. Be careful though if your column header is also a number, because then it will include that, so then use a -1. The next thing is the arithmetic mean, so average, and Excel has an average function for that, so I can simply calculate the average again. Again, be careful if your column header is numeric. The standard deviation is available either as a sample standard deviation, so you can use standard def. Actually, these days, standard deviation, you can also do a population version. So if the data is actually the entire population, but not really sure why you would do that. Because if you have all the data, you don't need to run the test. Or you can just type in the value here if you have a known population standard deviation. The next thing is then to calculate the standard error, which is the standard deviation divided by the square root of the sample size. The formula is showing the population version, so as an estimator for this, usually the sample standard deviation is used. We then use for our z statistic, we calculate the difference between our hypothesized mean and the actual mean, and we divide that over that standard error. Finally, we can then obtain the two-sided significance level. We can do that by saying, well, we take 2 times and then 1 minus normal s-dist, the absolute value of the z value, and cumulative set to true. You can also use the Euler norm s-dist, and that gives the same result. In this case, it's below 0.05, which is the usual threshold. Therefore, we would reject the null hypothesis and therefore say that in the population, most likely the mean will not be 49. So we have a significant result. Alright, I hope you found this video helpful, and thank you for watching.